Hi y'all, this is an example of function notation and functions represented by formulas. So we've done a little bit of working with functions represented by formulas when we were looking at linear functions, but this is something we definitely need to focus on. We'll do a lot of this in the future, so we need to understand exactly what we mean if we use function notation to ask for information about a function represented by a formula. So I'm just going to start us off with a function that's not too messy. So this is quadratic function, h of t equals 2t squared minus 3. And I'm going to start with evaluating functions represented by formulas. So I would like to find, and I have a whole list of things. So let's start with h of negative 2. So again, we did just a little bit of this in the previous section, but I'm not assuming that you've done tons and tons. So we're going to start with nice simple things like plugging in specific numerical values. Okay, so what you really want to get comfortable with here is that when you are given the definition of a function, this part right here where I tell you what h of t equals, you want to commit to that completely. So this is the rule that function h will always follow. If you plug something into function h, it is going to take whatever you plugged in, it will first square, then multiply by 2, then subtract 3. We'll do that to every single input that you give it. So if we're going to give it negative 2 as an input, it's going to take the negative 2, it's going to square it, multiply by 2, and subtract 3. So it really does just look like replacing all of the t's in the formula with your input, but I really want you to think about it as following a rule. I have very deliberately put parentheses around the negative 2. If you just wrote this as negative 2 squared, that would imply that you should square the 2 and then multiply by negative 1. This is a weird thing, but it's a good way to think about negative signs. We think about them as attached to whatever they are sitting next to by multiplication. So order of operations says you would first apply the exponent and then apply the multiplication. If we really want to square the whole thing, square the negative 2, let's just say this, these are not equal, then we need to throw parentheses around that. So this is 2 times 2 multiplied by a negative 1. This is a negative 2 multiplied by a negative 2, and that is what we want. So if in doubt, put parentheses around your input. You will never be wrong to put them there. It's possible to be wrong if you don't put them there. Okay, so if we square negative 2, we will get positive 4, and we should. If we square 2 and then apply the negative sign, we'll get negative 4, and we would be wrong. So let's see, negative 2 squared is 4. If I multiply 4 by 2, I get 8. And if I subtract 3, I get 5. So h of negative 2 is equal to 5. Okay, I'm going to switch colors so we can keep track. Let's make it a little bit messier. I would like to now plug in something that involves a variable, and in fact, to show you what gives people the most trouble, I'm going to plug in something that involves what we're using as our input variable. So we are being asked to plug in a 5t to function h. So very first thing, we should be looking for what is function h, and function h is represented by this formula. So again, it will always follow the rule. Your input will be squared, doubled, and then have 3 subtracted from it. You don't want to get attached to whatever variable is stuck in here. It's just a placeholder. So really what this means to me is h of input is equal to 2 times the square of your input minus 3. So that t up there really is just a blank place, and it shouldn't throw you off, hopefully, if you're asked to input something with t's. Okay, so we're going to take our 5t, our input, we're going to square it, double it, and subtract 3. When we square 5t, again, the parentheses are important. If you don't include them, you might be inclined to think that you're only supposed to square the t, but you're supposed to square your entire input. So we should get a 25t squared. And then if we multiply that by 2, we're getting 50t squared minus 3. really, really important that you realize you're done here. For some reason, people are very tempted to then say, oh, well, set that equal to 0 and solve. And that's not what this problem was asking for at all. When you see a statement like find h of 5t, that's saying plug 5t into function h and tell me what you get. It's not expecting you to find specific values of t. I see a couple places to get some confusion about distributing. When I square both parts of this, I'm not using any distributive property. I'm just saying that 5t squared means multiply a 5t by a 5t, which will give me 25t squared. When I multiply that 25t squared by 2, I am also not distributing. Remember that distributive property says if you're multiplying something by a sum or a difference, you can multiply the two terms in the sum or difference individually. There's no sum or difference here, so there's no need to multiply. This is just like saying 2 times 25 times t squared, and there's no reason to multiply the t squared and the 25 by 2. We would just say 2 times 25 is 50, which then still needs to be multiplied by t squared. So this is my answer, and I don't want to go any further than that. If you do end up with something factorable, it's completely valid to factor it, but again, remember that it is not equal to 0, so it's certainly not necessary to factor it. Just a little bit of extra work. Okay, let's compare that to 5h of t. So if I am asked to find 5h of t, that's 5 times h of t, or 5 times the output from my function. So in the previous one, I took my input t that I started with, multiplied it by 5, and plugged that in instead. Here I'm supposed to plug in a plain old t, and then multiply whatever I get by 5. So that 5 should get multiplied by h of t, which is just a 2t squared minus 3. If you plug t into h, you get 2t squared minus 3. If you then multiply that output by 5, you're going to get 10t squared minus 15. Here I am using a distributive property. I am multiplying a difference by a number. That distributive property tells me that it is perfectly valid to multiply each of the individual terms by that number and then calculate the difference. Okay, working our way up a little bit in messiness. Next, I would like to find h of t plus 5. So interestingly, addition, which we're super comfortable with, it's usually people's favorite arithmetic operation to perform, can get us in a little bit of mess when we're doing algebra. So if we want h of t plus 5, again, following the rule for h, we're supposed to take the t plus 5, we're supposed to square it, multiply it by 2, and subtract 3. Just like before, it's really important to realize that you can't distribute exponents. T plus 5 squared means you should multiply t plus 5 by t plus 5. So we're going to get 2 times t squared plus 10t. So here our outside is 5t, our inside is also 5t. When we add that up, we have 10t's. Plus our last is 25. So we have a 2t squared plus 20t plus 50 minus 3, which is a 2t squared plus 20t plus 47. Again, make sure you don't then set this equal to 0. There's nothing in the problem that says this should equal 0. This is just saying if I plug in t plus 5, I get out 2t squared plus 20t plus 47. Okay, one more, the messiest one. Let's see if we can write the beginning of this before I move my page up too much. Last one I want to do here, I've lost my color, is to evaluate what's called a difference quotient. This is kind of the big thing going on here. we're trying to prepare ourselves to be ready to simplify some of the messy things that we will run into when we're taking calculus. And a difference quotient is one of those things. So I don't need you to recognize a lot about difference quotients, but I do think it would be really great if you recognize that it looks something like a slope. So I'm seeing here that I'm taking a y value minus a y value. That's definitely a rise. And I'm dividing it by the appropriate run. Because we're not working with a linear function, I would say this is actually an average rate of change that we're calculating in kind of a general way. I don't need you to go any further with it than that, but if you're recognizing that as an average rate of change, you're in really good shape. So algebraically, to actually calculate this thing, we have a few steps to work through. We're plugging two different things into our function, and we're going to get two different outputs. And once we get those two different outputs, we're going to go ahead and subtract and then divide by 5. So I'm going to number here so that you can see where everything came from. The first thing I'm going to do is plug the t plus 5 into my function. And actually, I can cheat a little bit, so I'm going to write this step just so that you could see what to do if we didn't have the last part. But we've already done the work for plugging t plus 5 in. If you plug in a t plus 5, you should square it, double it, and then subtract 3. So you can see this is exactly what we did up above. So here is the h of t plus 5. We are supposed to subtract an h of t. An h of t is a plain old 2 times t squared minus 3. And I'm including brackets here because I want to be really careful. If I'm going to subtract h of t, I need to subtract both the 2t squared and the negative 3. So it will end up being negative 2t squared plus 3. This is the number one mistake I see people make on difference quotients. They forget to distribute the negative and things don't simplify nicely like they should. The last thing that I need to do, so that was our number 2, is divide all of that by 5. The rest of this, I think I can move up now, is just some messy algebra and simplification. Again, I get to teach us a little bit here because I've already carefully worked through simplifying h of t plus 5. So I already know that when I square the t plus 5, I'll get this mess. I then distribute 2 and subtract 3, and I end up with 2t squared plus 20t plus 47. So if I had not already done the work, I would work through that carefully, exactly as above, first squaring, then distributing, then subtracting. From that, I need to subtract a 2t squared and add a 3. And then when I'm all done, I'm going to divide by 5. I can start to combine a little now that I've dealt with all the mess in parentheses. I'm seeing that the 2t squareds will wipe each other out. I'm going to try and be really clear here. This is additive cancellation. So a 2t squared minus a 2t squared is 0. So I can just wipe those out. Not to be confused with canceling out something from the fraction by dividing. So those are gone, but I want to be really clear in what way they're gone. I see that I'm left with a 20t plus a 50, and I need to divide that by 5. If you're dividing the whole fraction by 5, you want to make sure you really do that. So you either need to look at this as factor a 5 out and then cancel it, or make sure you divide 5 into both terms in the numerator. So 20t divided by 5 is going to be a 4t, and 50 divided by 5 is going to be a 10. So the value of my difference quotient is 4t plus 10. And basically what this will do is if you pick any starting t value, it'll tell you the average rate of change from that t value to the one 5 units to the right. So again, I don't need you to try and memorize a ton about the average rate of change part of this, but recognizing that that's what you're calculating here is going to really help you in the future. Okay, this is kind of a long one, lots of parts. So one more thing here. We've done lots of evaluating. We should also be able to do some solving. So just like with graphs and tables, I should either be able to give you inputs or outputs. If I give you outputs, the goal will be to solve for your input. So for example, I could ask you to solve h of t is equal to -1. The biggest trouble I see here is just misunderstanding of the original statement. I'm not defining a new function h of t. I'm saying take the function h of t that you have and set it equal to -1. So find out what would make the output of your function equal -1. So basically, I know that h of t is 2t squared minus 3, and I want to know when that will equal -1. And there's the equation that we're trying to solve. This actually looks really nicely set up to use square roots. I have a single t, so I'm just going to reverse order of operations to solve. The last thing happening here is minus 3. So I'll add 3 to both sides, which is going to give me 2t squared equals 2. The second to the last thing happening is multiplication by 2, so I'm going to divide both sides by 2. 2 divided by 2 is 1. The last thing happening to t, I guess the first thing happening to t, is that it's being squared. To get rid of a square, we're going to square root both sides of the equation, hopefully being very careful to remember that when you introduce a square root into an equation, you need a plus or minus. There are actually 2 different numbers that you can square to get 1. And here I hope that we all spot that yes, we're taking the square root of 1, but conveniently the square root of 1 is still 1. So I have t could be plus or minus 1, 2 possible solutions. Since this was a quadratic equation, I shouldn't have to worry about extraneous. I should be able to keep both. If you want to go back and check and make sure that you didn't make any mistakes, excellent. Go back and plug in 1 and -1 to your function and make sure you really do get -1 out. Okay, one last solve and then we'll be done with this one. We could also solve h of t equal to t. And I just want to do one more because this, even more than the last one, tends to get people thinking that I've somehow defined a new function h of t and they have no idea what I'm expecting them to do with that. And that's not at all what's happening. H of t, as long as I'm within this problem, always means this rule right here. So I'm supposed to take my formula, set it equal to t, and figure out which inputs would make that true. So 2t squared minus 3 is equal to t. And this one is not looking nicely set up for square root method, so I'm going to go ahead and set it equal to 0. I'm going to subtract t from both sides. And that actually looks like it might be factorable. As always, if it's not factorable, it's completely legal to use a quadratic formula, but you should be trying factoring first. So 2t squared is going to split up to a 2t and a t. And then, things are chiming at me. If I want to get my inside outside to be a -t, I'm thinking that I want a 2t and a 3t, with the 3t being negative and the 2t being positive. So there's 2t minus 3t to get my -t in the middle. That looks great, which means that the first factor is going to equal 0 if t is equal to 3/2, and the second factor is going to equal 0 if t is equal to -1. Again, this is quadratic, so you shouldn't have to worry about extraneous solutions, but if you want to double check to make sure you didn't make a mistake, you can go all the way back to the function notation if you want to. You can try plugging 3/2 into our function and make sure that you also get 3/2 as your output, and you can try plugging -1 into our function and make sure you also get -1 as your output. So basically, we've just identified when you can plug a number into our function h and get back that exact same number as your output. All right, thank you for watching.